Hello dear students, I am going to cover evaporation chapter of pharmaceutical engineering. We will cover following points. Definition of evaporation, factor affecting evaporation, classification of evaporators, working construction and uses of evaporating pan, working construction and uses of evaporating step. Definition. Evaporation means simply evaporation from the surface of the liquid. Evaporation is a process of vaporizing large quantity of volatile liquid to get a concentrated product. Evaporation is an unit operation by which a solvent is evaporated from a solution by boiling the liquor in a suitable vessel and withdrawing the vapor, leaving a concentrated liquid residue. And equipments used for evaporation are known as evaporators. Now, various factors affecting evaporation. First one is the temperature. The higher the temperature, the greater will be the evaporation. Time of evaporation. If the time of exposure is longer, greater will be the evaporation, provided the constituents are thermostable. Exposure of a drug to a relatively high temperature for a short period of time may be less destructive or harmful for principal active constituents than a lower temperature with long exposure period. Next one is the type of product required. Type of product required sometimes decide the apparatus for evaporation. Open pen produces liquid or a dry concentrate. Film evaporator yields liquid concentrate. Agitation. Agitation is required for evaporation. Agitation helpful for evaporation process. Next one is vapor pressure. The rate of evaporation is directly proportional to the vapor pressure of the liquid. Lower the external pressure, the lower the boiling point of the liquid, and hence greater will be the rate of evaporation. Surface area. Greater the surface area of the liquid, the greater will be the rate of evaporation. For this reason, evaporation is conducted in evaporators with larger heating surface area. Next one is economic factor. Economies of labor, floor space, fuel, and various types of materials used during evaporation are of primary consideration. The recovery of solvent and utilization of waste heat are also important as they involve some reduction in cost. Next we will discuss types of evaporators or classification of evaporator according to the form of the movement. First one is based on natural circulation evaporator. Second is a forced circulation evaporator. Third one is film evaporators. Natural circulation evaporators again divided into conventional pan evaporating still and short tube evaporators. And film evaporators is again divided into pipe film evaporator, long tube evaporators, and in long tube, two types of evaporator included climbing film evaporators and falling film evaporator. According to their name, one is climbing and another one is falling film evaporator. This is a simple evaporating pan. Construction. The apparatus consists of a hemispherical pan. The shape is hemispherical. The hemispherical shape gives the best surface volume ratio for the heating and the largest area for separation of vapor. Constructed from a suitable material such as copper or stainless steel and surrounded by a steam jacket. The dilute solution is taken in the pan. Steam is introduced through the steam inlet into the jacket to heat the pan. In these evaporators, the movement of the liquid results from convection current set up by the heating process. Convection, we know that conduction, convection, radiation, these are heat transfer mechanism. So here is convection, current set up by the heating process. in the hemispherical pan. The concentrated liquid is collected through the outlet placed at the bottom of the pan. Advantages of conventional pan is simple, cheap to construct, easy to use, clean and maintain. Disadvantage that total liquid is heated over all time, which may unsatisfactory for heat sensitive or thermolabile materials. Also, many products give rise to foaming, and heating surface is limited and decreases proportionally as the size of the pan increases. Only aqueous liquids can be evaporated in these pans. Pan evaporation cannot be done under reduced pressure. So there are a few changes um, done in a conventional pan, and the second one is evaporating still. This is a figure of evaporating still. Here is again a evaporating pan which covered, and again condenser, and then next condenser is attached. Its construction it is a jacketed evaporating pan with a cylindrical cover that connect to the condenser to a condenser. The overall assembly is called still. The cover is clamped with the evaporating pan. Its working is the dilute solution is fed into the still. The cover is clamped. Steam is introduced into the jacket. The liquid is evaporated and condensed in the condenser and collected. The product, that is concentrated liquid, is collected through the product outlet. And again, it's the advantages and disadvantages: simple construction and easy to clean and maintain. Vapor removed by condensation, so there is not any saturation in the atmosphere um, by the vapor. Allows the equipment to be used for the solvent other than water. Receiver and vacuum pump can be fitted to the condenser, permitting operation under reduced pressure, hence at lower temperature. And its disadvantage is just like conventional pan, it's again based on natural convection only. All the liquid is heated all the time. The heating surface is limited. Its uses aqueous and other solvents may be evaporated. Thermolabile materials can be evaporated under reduced pressure. Thank you. Thank you very much.